two train drivers, Santosh and Rekha, are both in the engine of a train of length 60 meters. So now train has length, and so it's important to draw an extended train. You can't put a dot. Okay. So Santosh is here. Rekha is also here. Okay. So they are basically talking at the engine of the train. So that means the train is going to move this way. Now, as the train enters a platform, that means the train is just entering the platform here, which means this must be the platform. I don't know how long the platform is, but the idea here is that the platform starts here, and at the initial time instant, this is where the engine is aligned with the platform. Okay. Now, as the train enters a platform, Rekha starts walking with uniform speed towards the guard compartment. Well, if this is the engine, where is the guard compartment? This is the guard compartment. So Rekha is now going to walk like this. This length is given. This is 60 meters. Okay. Now Rekha walks at uniform speed inside the train. So as the train keeps moving forward, Rekha is moving backwards for a while until she reaches the guard compartment. And then she picks up her handbag and then she walks back towards the engine compartment. Correct? So this train is going to move like that, and by the time maybe somewhere here when Rekha comes back, how much time has passed? Let's see. She reaches Santosh after 40 seconds. So that means Rekha walks like this and comes back. It takes her 40 seconds. Well, she is doing this uniformly. So how much time to go this way? 20 seconds. And how much time to go that way? 20 seconds. So she goes 60 meters in 20 seconds inside the train. So what is her speed inside the train? 3 meters per second. So we can say that Rekha is going to walk inside the train at 3 meters per second. Just as this train is passing this platform. The train starts passing the platform. So after a little while, what is going to happen is that this train will basically come somewhere here. Okay, this much length. And when the train comes here, which is going to take some time, where do you think Santosh is? Well, Santosh hasn't moved from the engine. So where do you think he is going to be? Here. So has Santosh now passed? No? Santosh. Has Santosh passed the platform? No? Santosh starts here, Santosh ends here. Well, just passing, right? He's just going to pass. So I'll just wait for a fraction of a second and Santosh is here. So Santosh has passed. Has the train passed the platform? No. But has Santosh passed the platform? Yes. Okay. Now this train keeps moving. But where do you think is Rekha? Because she is still walking. She is going to take 20 seconds to get to this place. But at that time, well, let's think about it. Santosh says that it took him how much time to go from here to there? Let's read the question. It says, when she meets Santosh again, which is 40 seconds later, she tells him that she took, that is, Rekha took 12 seconds to pass the platform. Santosh says, no, I took only 8 seconds to pass the platform. So that means Santosh went from here to there in how much time? 8 seconds. So this diagram, so suppose I took this diagram and marked this like that. From this diagram to this diagram, it took how much time? 8 seconds. The time gap between these two diagrams is 8 seconds. This way. This is 8 seconds after. But 8 seconds, do you think Rekha would have come to this end? When does she come there? 20 seconds. So where do you think Rekha will be? Somewhere here. And is she walking this way or that way? She's still walking this way. Right? Because she has not even reached the guard compartment. She takes 40 seconds to reach the guard and get back. Right? So which means 20, 20. But this is only 8 seconds. So she's still walking this way. But do you think Rekha has passed the platform?
No.
Why?
Because
Because she
she's
is still here. Platform is there. So she's going to take some more time to pass the platform. So what is going to happen is after a little while, the train looks like this. And Rekha is here. Now is Rekha walking this way or that way? She's still walking this way. How do you know? Because it takes 20 seconds for her to reach this point, but she has already passed the platform 12 seconds later. So she is still walking this way, and the time gap between this diagram and this diagram is how much? How do we know it's 4 seconds? Because from here to there it took her 12 seconds. So this was 12 seconds. So this is 4 seconds. Total 12 seconds. This diagram is time 0, time 8, time 12. And when does she reach the final compartment? And where is Santosh? Santosh is here. Right? After some time, what's going to happen? Maybe the train looks like this. And this is when Rekha has just reached this end, picks up her handbag, and then starts to walk this way. And Santosh is here. When does this happen? 20 seconds from the beginning. Already this is 12. So how much more time? 8 seconds more. I am not going to specifically mention this. I don't need this, but if you want, I can say that this is how much more time? 8 seconds more. Because 12 plus 8, 20. I hope everybody understands the diagram. Clear? Okay. Now, you know that Rekha took 40 seconds to go and come. 60 plus 60, total 120. 120 meters in 40 seconds. So, what was her speed? 3 meters per second. We already calculated that. Or you could have done 60 meters. Rekha walked 60 meters. But Rekha walked 60 meters inside the train. It was not 60 meters from the ground. Because in 20 seconds, actually Rekha didn't walk back, Rekha walked forward. Rekha thought she was walking back, but then the train moved so much forward that overall from the ground it will still be forward. But we only care about how much she walked back on the train. Okay, let us now think a little bit about this situation. This was how much time? 12 seconds. And this is how much time? The gap between these two time wise? 4 seconds. Correct? Now, Rekha used to be here, right? Remember? Rekha and Santosh were together. And Rekha has moved from here to there in how much time? 12 seconds. How do we know? Well, we just look at it. No, this was 12 seconds. At that time they were together. If the train just moved all the way, suppose I just put dotted train thing here, that is Rekha never, if Rekha never walked back, Santosh and Rekha would have been here. Because Santosh was never walking back, right? Correct? But Rekha has actually walked back this much. How long? 12 seconds. At what speed? 3 meters per second. So what do you think is this distance? Because she walked this way. 12 into 3. Because 3 meters per second into 12 seconds. So therefore 36 meters. Correct? But if you think about Santosh, Santosh has moved from here to there, which is 36 meters, like that, in how much time? When was Santosh here? Santosh was here at t equals 8. Santosh was here at t equals 12, which means a gap of 4 seconds. So in 4 seconds, Santosh has moved 36 meters, which basically means the train has moved 36 meters. But from here to there, how much time does it take? 8 seconds. So if in 4 seconds Santosh moves 36 meters, in 8 seconds Santosh would have moved how many meters? 72. Because 36 plus 36, because every 4 seconds he is moving 36. This is 8 seconds. So in 8 seconds he would have moved 72 meters. Okay, we do this without doing too much of calculation. If we want, we can do a little bit more calculation. We can end up saying, well, Santosh or the train is moving 36 meters in 4 seconds. So if the train speed is v, then v into 4 is equal to 36. V is equal to 9 meters per second. Whose speed is this? Train speed, Santosh speed. Santosh isn't moving inside the train. So if the train has a speed, Santosh has the same speed. But if you take Rekha, Rekha is moving back 3 meters per second, but the train is moving forward 9. So Rekha's actual speed on the ground will be 9, 3. So imagine you walk 9, but then this room itself moves back 3. Okay. So effectively how much have I gone forward? 6. So Rekha has only moved 6. So 6 into 12. What is 6 into 12? 72. So from Rekha's point of view, she has moved 6 meters per second into how much time? 12 seconds, which is 72 meters. But from Santosh's point of view, what is the speed? 9 meters per second. And how long did he travel? 8 seconds. He started here and he ended there in 8 seconds. So therefore, how much? 9 meters per second into 8 seconds, which is 72 meters. Now you can do it like this by finding that speed, train speed. You can do that in terms of Rekha's speed, or the best way is to understand this is to say Santosh has travelled in 4 seconds 36. So in these 8 seconds you have travelled 72. Therefore the platform length is 72. Now you should spend a little bit of time to understand what is going on here. But if you notice, there is a train, there is a platform, then there are these two people. Well, Santosh and the train, engine of the train, you can basically stick them together. So put a lot of Fevicol on the seat, Santosh seat. So Santosh is stuck to the train. So actually there aren't 4 objects, there are only 3 objects. Train engine or train seat, and then, which is Santosh, and then Rekha who is moving in the train, and the platform, which is the ground. But still there are so many objects that are moving, right? At least 2 objects that are moving. Rekha is moving differently, train or Santosh is moving differently. Platform, of course, is at rest, which is why we need these diagrams. Okay, once you draw the diagram, does it become obvious? Is everybody clear about what is going on? Okay, so spend some time, then you will suddenly it will click at one point and you say, ah, now I know why it works. Okay, so you have to spend some time because these diagrams take a little while. We are going to study about acceleration. You will find that many questions with acceleration are very easy. As a concept, it may be a little harder. If you look at this, what concept does it use? Velocity into time is displacement. That's all, one idea. But it obviously involves a lot of messy ways of thinking about that one idea. As a formula, you are not using anything more. 8 seconds, so much distance has been travelled. Okay. The more complex way of doing this would be to say, let us say this was V. Then this fellow has moved in 8 seconds, V into 8. How much? That would be the length of the platform. But if this is V and Rekha is moving 3 that way, then Rekha's speed would be v minus 3 on from the ground, because train takes her v, but Rekha walks back 3 every second. But Rekha takes 12 seconds to cross the platform. So both must be correct. Well, if both are correct, v into 8. So 8v must be 12 times v minus 3. Now this is an equation we can solve. 4 into 2, 4 into 3. So 2v is 3v minus 9. And so if you take this and subtract it and bring it to that side, what do you get? V equals 9. And if you know v equals 9, 9 times 8, 72. Now this way of solving is also okay. But what happens in this way of solving is you are not going to get a complete picture of exactly what is happening step by step. You should know how to do this. We will later spend more time using equations to solve things. But that's not the best way to imagine what is happening. It is just a way of, so what you are doing effectively when you do this is to surrender to mathematics. You are saying, I don't know the answer, but these equations somehow know the answer. So let me put it into equation form, and then the equation will tell me the answer, which is, by the way, not bad. Okay, a lot of physics basically just simply tells mathematics to say, solve this problem for me and give it. It is like using a calculator. If I punch some bunch of numbers and say multiply this into that, we don't know how it does it, but finally it does and throws up an answer and we trust it, right? So think of mathematics doing calculation job or calculator's job for physics. But ultimately, who gave that question to the calculator? We gave. So hopefully we understand what we mean when we are saying what is 8 into 7. The calculator may tell you what is 8 into 7. But if you don't know what it means, there's no point using the calculator. To understand what this equation actually leads to, you must have a clearer picture of how it works. Okay, so do it step by step and analyze it. This may look a little messy, but there is no real solution to learning this. Do it step by step. After some time it will click. Later you may want to just combine this into one diagram. So you will just put this there itself and then you say, okay, this diagram we will count it as two things we will combine into one diagram. One part alone we will do separately. But that is just shortcut. This is not a very clear-cut way of doing it. Like in the single body movement, what did we do? We combined everything into one diagram. Here we have kept everything as separate diagrams. Later on you may want to say, let me move this alone. So this will be the diagram which includes two parts. The second diagram includes the third part. This is a shortcut in the sense that you are being lazy, you don't want to draw three different diagrams. But don't do it now, do that later after you are very comfortable with solving these problems. Okay.